like shove a really big straw in the ground and then like stick their thumb on the end of it and then pull it back up and then release it on some sort of surface without jumbling them all up. Something like that. This is why I'm not the one in charge of these projects.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 91. We are in our What is Science unit. Cheryl, we've been talking about a few different sciences. We've hit some of the big three is what I would call them, right? Biology, chemistry, and physics. Those are the three that are the most traditional to do. And so I think we're going to move into a few of the other ones that are maybe a little less well known, but also kind of cool. Which one would you like to do this week?
We're going to talk about geology.
Yay, geology.
Yes. Bunch of rocks. I'm excited.
Bunch of rocks. Because that's the only thing that geology is. It's rocks.
Just a bunch of rocks. Yep, bunches of rocks.
Bunches of rocks. All right, let's dive into the pre-assessment then. What do you think geology is, Cheryl?
The study
a bunch of rocks.
Rocks and minerals. Maybe the study of the earth.
Well, which do you think?
Oh gosh. No, I don't know. I'm gonna go with the first one, rocks and minerals.
Okay.
Because there's also something called earth sciences. And if geology was a study of the earth, then why would we say earth sciences? That's gonna be my thinking there.
Okay. Alrighty. And what are rocks and minerals?
Oh no. Oh my gosh. Okay, Ryan, I have to tell you something. So my husband likes rock hounding. Do you know about
like
rock hounding? He's not a dog, he's a human. But
he takes a dog to go find rocks?
No. I mean, when I had Gracie, she would come occasionally. She did enjoy it. So rock hounding is a thing, like you could Google it.
Okay.
And people go and look for like special types of rocks in different places. And because the internet can be pretty cool in some ways, there's like a whole internet community for like, you can go to this place to find agates or like whatever, geodes, all sorts of things. And so we've gone several times. Specifically, we've gone digging for crystals. And we've been successful. I'm going to show you, like, see if I can show you. See that guy?
Oh, is that quartz?
I don't understand enough about crystals to know if crystals are their own thing or if they have to be a category.
Okay.
But I'm going to guess yes. Here's a big one too. This one's broken, but you can tell how big it would have been.
Yeah.
Just by by the width of it.
Yeah.
So anyway, I'm sharing that with you because when we're like in the ground digging for these crystals, I realized we're like digging in the earth. With our shovels and our like sifters and all of these really cool. Yeah, it's real cool. I was realizing just how little I know about how any of these things develop, because he'll tell me like we're talking about the crystals and we're saying like, oh, spring is good to go because after the winter and the snow melts, then like it uncovers more or like washes more, something like that. And I was like, oh, so did the crystals like grow over the winter? And he's like, well, no, like they grew over like many, many, many years. And I was like, oh gosh, okay. So I still don't understand how that happens. Or like he'll point out like a big, big rock that we'll see somewhere with little like holes missing in it. He's like, oh, those are agate holes. And so it means like there was one kind of rock and then agates grew in these like bubbles, I think, that were there and then like got knocked out or something like that. So like it's these different somehow all these different types of rocks like grow in different ways and are made of different things. And because of that, they have different properties, but then like they're growing all amongst each other, which is, I guess, what happens with nature too. But like, I mean, it is nature, but like with
You mean
plants,
like
it's
living
not like,
things, plants?
yeah,
Yeah.
sure. Like plants don't only grow apart from each other, they grow like
Right.
amongst each other.
Yep.
There's something weird and amazing about it with rocks though, when you're like, there's just one kind of rock here, but it's not just one kind of rock because there's these other things happening
Mm-hmm.
here too. And I don't understand it. I mean, I also know the formation of them is like a long, 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 long time. So I don't know like then how over time like one grew inside of the other or things. It's mind blowing
Mm.
to me. Um, it's very cool. But then I also don't know what geologists do because that sounds very much like we were talking about in a previous episode. That sounds very much like an elementary school job. Like when you're like, I'm gonna be a fireman, and then it's like, I'm gonna be a
Mm.
geologist and study rocks. And I was like, well, what are they other than studying them? Like, I don't understand how scientists are like have a profession of just studying something, but I guess it has to be like through a university or through someone who's like funding the study.
Mm.
But then like,
Yep.
are geologists doing anything other than studying? Or are they just learning and
Mm.
that's what they do? Or are there
Mm.
actions involved in their work? Because I don't even know what they would do with their time or like, their knowledge.
Okay.
I just realized how like condescending that
Well, except I know that you don't mean like, what do they even do, really? That's not what
yeah.
you mean. You mean,
Yeah.
I know they do stuff, but I don't know what it is.
Yes. Or do
No?
they
You don't know
not?
that they
Like,
do
is it
stuff?
just do geologists like do things? Are there new I'm assuming there's like new discoveries happening, but then what are they doing with that knowledge and that research? Like science
Mm.
like progresses so many things forward
Yeah.
and how are geologists progressing things forward
Mm.
other than
Yeah.
being like a docent at the Mount St. Helens Museum or something, something like that.
Which generally aren't geologists, but yes,
Fair.
something like that.
Yeah,
Okay. I think we got a lot to talk about.
amazing.
Let's start at the beginning with what is geology. And you talked about rocks and minerals, and rocks and minerals are definitely part of geology. And they are probably the part that is the most consistent throughout different kind of branches of geology because the
Okay.
geo means earth, right? Geology. So
It
literally it is the
was
study of
Earth.
earth. Yeah. Geo does mean
Okay.
earth. And then the question you asked is like, well, then what are earth sciences? Well, there's a couple of things to that. One is that earth sciences is generally a broader statement than just geology, because, for example, meteorology is also an earth science, but depending
Oh,
on how you want to classify it, may not be geology. Because generally, geology is thought of as the stuff like actually on the ground or
okay.
inside the ground.
Yeah, yeah.
But in some instances, you may also be able to find that people would say that meteorology is a geology because it does deal with the earth. The other thing is
Interesting.
when you hear earth science, typically you hear that in an educational setting because,
Yes.
for example, for me, my 8th grade science class was earth science,
Oh,
which
okay.
was not geology. It was broader than that. But my 7th grade science was not biology either. It was life science. It's sort of a way of talking
Mm,
about it in a more general, less detailed way. That could be what you're thinking of as well,
yeah, I
potentially.
think so. Okay. So my inclination with geo being Earth. I was thinking geo meant Earth.
Yeah, it
Okay.
does. Yep.
Cool.
Yep. Yeah. There's a lot that goes into geology and things. So definitely rocks and like the rock cycle. Do you remember the rock cycle?
No.
Did you
There's
never
a
learn the
rock
rock
cycle?
cycle? Yeah. Did you
That's
learn about
cool.
the 3 types of rocks?
Igneous
Uh-huh.
and some others.
And 2 other ones. Uh-huh.
Yep. Yeah.
Igneous, sedimentary.
Yeah.
Nope. Yeah.
Yeah. Sedimentary.
And metamorphic.
Okay. Yeah, no, those are all very familiar. I remember learning
Okay.
those words. Yeah. Yeah.
Then you probably did the rock cycle as well. The idea of where rocks come from, they can be recycled back into the earth, right? An igneous rocks are rocks that come from lava or magma. And that's like quote unquote new rocks. And then sedimentary rocks and metamorphic rocks are made of other types of rocks that get smushed or compressed or heated or different things together to make one type of rock into another type of rock. And those are the things that take really, really long periods of time to happen. You talked about long amounts of time. Those are the things where like to get the high pressures and the high temperatures and to make those transformations on the molecular level, that's where those occur.
Okay. Interesting.
Does that sort of make sense?
Yeah, it does. I'm sure I learned about it. It's funny, just that term isn't ringing a bell, but I'm sure if I learned about those other things, I probably learned about the rock cycle too.
Probably.
Yeah.
And maybe not. Maybe not. One of the things that you talked about was crystals, because you go rock hounding and find crystals and things. And you said, I don't even get crystals. What is the whole deal with crystals?
Yeah.
Well, I've got a really simple example for you. I feel like we talked about this maybe in our hot and cold unit or something early on in the podcast. And I don't remember what conclusion we came to, but have you ever made rock candy?
Okay, we did talk about this, and the answer was no, and the answer is still no. Well, okay, in my adult years, I'm pretty sure in like elementary school I did. And then you were like, you should do this with Jack. And I was like, I should do this with Jack. And I still have not, but like, I should do it with Jack.
You should do it with Jack. And you can either do rock candy, which is with sugar, or you can just do it and not eat it and do it with salt. Salt is a lot simpler. Same basic idea. Either way, you just dissolve as much as you can into really, really hot liquid, because that'll super saturate the solution. So you can dissolve more in it when it's hot than when it's cold. And then you just set a string in the liquid, let it evaporate. And as the water evaporates away, the salt or the sugar or whatever is going to be left, and it's going to start sticking to itself. And as it does that, it's going to form a crystal structure. What crystal basically means is a pattern. There's a pattern that is repeated over and over again in the shape. So if something's not a crystal, it's generally referred to as amorphous, which means the molecules can be arranged in all sorts of weird different ways.
Yeah.
Think all the way back to, do you remember your favorite little model here?
Yes, the little Mickey Mouse molecules.
Yeah, which is what actual molecule?
H2O.
Yep, water. And do you remember when we looked at some animations, some simulations about how they kind of like snapped together when they were solids?
Yeah.
Right? And there was a particular shape. That is a crystal structure where the molecules line up in a really specific way. That is, on a molecular level, crystal. But as you have those building on top of each other, the macro scale structure of it, what we can see, mirrors what the microscopic structure is of those molecules. And so like salt crystals, for example, are very, very jagged, because a salt compound, when you've got salt, it's actually an ionic compound. It's very, very like grid-like. And so you see that with salt is it tends to be pretty sharp edges, very square, rectangular, as when you make salt crystals. Not all crystals form that way. Some of them, like some of the ones you showed, can be like long and kind of stretched out. And again, that reflects the shape that's happening on a molecular level, which I think is really cool. The fact that you can have something really, really tiny that gets reflected into a really large scale.
Yeah, they're so interesting that they have such defined edges too, because most rocks that you're finding are kind of like all sorts of shapes and lumps and everything. And so
Right.
the fact that there's like angles on them feels more unique. But I have found that in all the ones we found, they are the same ratio. So like that's why I was
Yes.
showing you this one that was broken. You can tell how big it would be
Yep.
if you know, like, oh, that if it's that wide, that means it is this long.
Right.
Okay. Yeah.
Yes. Yeah.
It's so
And that's a
cool.
pattern. Yeah. It's very cool. I agree. I agree. And that gets to, you talked about a really, really long time. And yes, these things can take a really, really long time to form and to reform and do all of these things. And so oftentimes in geology, you are looking at millions, if not billions of years, depending on what you are studying. However, one of the things you talked about is like, what do geologists actually do? There is a research component, that there are geologists that are doing research. A big part of geologic research is often to uncover what happened in Earth's past, figuring out like,
Oh, cool.
how do we know some of these things? How do we know, what happened 2 billion years ago? There weren't humans around to see it. We don't have written records, but we can look in the rocks and see what was happening on the Earth in those times. For example, so this will be kind of cool. It's a connection to biology. You know that about 65 million years ago, we're pretty sure that there was an asteroid impact that led to a mass extinction, including the non-avian dinosaurs. Right? When you look around the world, you can actually find there is a very specific layer think of like the Grand Canyon, where you can see like layers and layers of rock, right? When you can get places where you can see layers, there's a specific layer that's at about the same geologic time. You work back in time, how old it is, that has iridium, which is a very specific material. It's a very thin layer, and it actually is from asteroids. It's not a substance that we really run into on Earth particularly, but it does exist out there in space. And so that is evidence that we have that an asteroid, in addition to the crater that's left over and things like that, but that there was actually an impact when it happened, and it got spread almost globally across, like you see this layer all the way around, because so much of it was pushed up into the air and then spread out and then settled, and then natural just formations of layers on top of each other. And so we have evidence of things that happened, that one 65 million years ago, which is crazy, but cool.
That's so cool. So they're like our historians that we have.
Yes.
I love that.
Yes. That's one level. You also have the extreme opposite level, where you can have volcanologists, people who study volcanoes. Yeah. And people who actively monitor volcanoes and are looking for, how do we figure out when an eruption is going to happen? How do we predict those? What are the signs that are happening inside the Earth that might lead to those? Earthquakes with seismology, right? Studying the waves that are inside the Earth, figuring out what the Earth is made of, what's inside the Earth. How do we know what the layers of the Earth are if we've never actually been all the way even through the crust? Have you ever wondered about that?
Yeah.
Do you know?
No, I mean, I just like, I assume that they're just like guessing with like, I mean, like educated guesses, but that haven't like scooped it out for themselves.
They have not scooped it out for themselves in that they've seen it. They use earthquake waves.
Are you serious?
Yep. There are seismometers all around the globe, and earthquake waves are waves, and they move differently through different materials. And when an earthquake happens on one side of the Earth, those earthquake waves can be felt all the way on the opposite side of the Earth. But they change. The angles that they change, the speed that they go, all of those things. And we can measure those differences and use those to determine what must be inside the Earth.
Wow. This all sounds really fun and really overwhelming. Because you
Yes.
have to have, like, such a strong foundational knowledge and then, like,
Yes.
so many records, just so many records to be able
Yep.
to build off of.
Yep.
I don't think I wanna become a geologist. I mean, I just don't wanna become a
That's okay.
scientist because all of these things sound really overwhelming to me, but also really fascinating, so it's fun to hear about
Yeah.
it, and then I picture myself doing that job, and I just, like, feel overwhelmed and like it's too much.
Well, it's good that that's not your job then, I
Yeah,
guess.
I know, it is really good that this is not my job.
Yeah. But does that help understand a little bit more about what geologists do?
Yeah, yeah, it really does. It reminds me of I think I've shared about my 8th grade science teacher before, the British guy who got very passionate about science, and there was an earthquake, let's see, that would have been 2001? No, no,
Yeah, that
no.
was
The
2001 was the
earthquake in
Nisqually
2001,
quake.
spring
That
of
was the last.
2001.
Yep. I don't think it was
No, I don't
spring. I
know if
think it
it's
might have been
spring.
fall. I think it was fall. But
Maybe it was fall.
regardless, yeah, here in
2001.
the Seattle area, yes,
Yes.
2001 was the last time we had a relatively major earthquake.
I was in science class, and as we all ducked below the tables, my science teacher started talking about what the Earth was doing at that time because he was
That's
just
so
nerding
cool.
out. And it was
Yep.
like, "Oh, yeah." It just made me think, like, I bet so many geologists just nerd out when there's an earthquake, even though there's, like, sad things that can happen if with
Mm-hmm.
serious earthquakes. It's like, I'm sure it's also like, "Ooh, but what does that mean?" Or, "Where else is this happening?" Or
Mm-hmm.
stuff like that. I'm sure it's very exciting to geologists too. So, yeah.
Yeah. Absolutely, absolutely. There's a ton of other things that geologists that can fall into geology and what they do and all of that stuff. So I'm definitely not capturing everything, but I did want to sort of just give you an idea of the wide range of things that geologists do. They can also do, I mean, a lot of geologists can be climate scientists as well and look at
Oh.
what ancient climates were like. And so looking at things like ice cores and figuring out, did you know that we can figure out exactly what was in the air millions of years ago because the little bubbles of gas have been trapped in ice, and we can drill these big, huge, long columns of ice and pull them up and then sample what the actual air is?
That is so cool.
Isn't that crazy?
That's so interesting. 'Cause that if you told me like, "Oh, could we know what the air is like?" I'd be like, "No, we can't. It's gone." But it's not gone. That's so cool.
Yeah. Some of it is
Wow.
actually trapped in the ice, and that is something that climate scientists, which a lot of them are geologists, can do and do research on ice cores to figure out what was the atmosphere like? How has it changed over time? Are we in a unique period of time when we talk about what's
Mm.
happening with our atmosphere, or has this happened a bunch before? How can we possibly know? There's this is one of the things that I think is cool about science. See, shoot, now I'm just like geeking out like
Say
crazy.
it, say
Is
it,
the
say it.
amount that we can know about things that you wouldn't think we could know, but just when you study a little bit deeper and you look for these patterns, there are things that we can learn and we can know with some confidence that even though we weren't around or we didn't see it or whatever, and we can still know these things to be true. It's very cool, I think. It makes me very excited, the things that we can know.
I love that. Wow, I'm way more excited about geology now.
Yay! And now, Cheryl, it's time for your geology quiz.
Okay, I was gonna make a joke. See, now we've reached a point in the podcast where I just explain the joke that I half thought of in my head. I was
I've
thinking about
noticed
something
that.
about rolling away. I don't know, we could say rock on. I don't know. something
Oh, there you go.
like that. Yeah.
I had trouble making, yeah.
You can tell that Ryan goes to like a lot of rock shows for
I
sure. Yeah.
totally go to the rock shows.
Yes.
The rock shows? Rock shows? Rock, like rock and roll, but also like geology, like rock? You're not getting
Yeah,
it.
I mean, that's why I said it in the first place.
Oh, I didn't know that's why you said it in the first place. Okay, gotcha.
I was trying to figure out your new joke.
Oh, no. It was the same joke.
Okay, cool.
Apparently.
Yep.
All
Good
right.
job.
Well, let's get, yeah, we're so funny. We are
Yeah.
hilarious.
Sure
First
are.
question for your quiz. What's the difference between geology and earth science?
Earth science is semi-real. It is a term used in education to mean geology and then some, such as meteorology. And geology is the study of the earth.
Yes, that works.
Okay, great.
What are crystals and why do they have the shapes that they have?
Crystals are, well, see, now I don't know how to actually define them. I'll start with the second half. Is that they have the shape because that's the shape of each little tiny cell, and then they all just like line up
Each
all
little tiny what?
perfect. Cell? Is it cell? Molecule? They don't have
Molecule.
cells. They're rocks.
Yep, they're
Each
not
little
alive.
tiny
They don't have cells.
molecule. Yep.
Thank you.
And then they just kind of build off of each other and all like it's like an organizer's dream, and they all just like stack and fit
It is an
just
organizer's dream.
perfectly, and then they stay the
Yeah.
same shape because I'm picturing Lego in a way too, but like just things that stack perfectly.
Okay, Cheryl, I just had a memory. This is going to be a tangent, but it relates.
Okay.
Do you remember when you were living in the mountains, the Cascade Mountains
Yes.
in Washington?
Yes.
And I drove out to visit you several times, I think, but at one point, and I'm pretty sure that I mentioned something that you can see from that last kind of like main road.
Columnar basalts.
Yes, look at that. You remember.
Yes,
Do you remember
I
what
do
those
remember
look like?
them. Yes. Yeah, they're
Go ahead.
they're like they have a similar like weird rigid shape that a lot of rocks don't have. So they're very distinct. And you're like, what's up with that? Why are they all uniform and organized with sharp edges?
Yes. And that is related. It's not technically quite the same thing because it's not the mineral, it's the rock, but that has to do partly with that crystal structure.
Cool.
So it's what's happening again at the molecular level, but it leads into those huge columns that have usually like 6 or 8, I think, sides, depending on what minerals are in there and how quickly they cooled and things like that. So yeah, you remember the columnar basalts. I'm impressed you remembered the name. Good job.
Well, you told me them when I lived there, and then I would notice them specifically. And I've noticed them, I think, a couple other places. You saw them in Iceland.
Yes, I did. And in Ireland, in Northern Ireland.
Oh, cool.
Giant's Causeway is a huge field of columnar basalts that you can like walk on top of. And, oh, it's very cool.
I love that.
Very cool. Awesome. See, I'm getting excited again. So, yes.
I love that.
And I think you were like, I'm not quite sure what a crystal is. Is that right?
I'm going to guess because I believe that you defined it. I don't remember the moment when you defined it. But I do remember how you described like the salt crystals and the sugar crystals of like it's what happens when the water goes away, essentially, is like it's what's left of like the minerals that are in the water, and then the water goes away and then they just like form these cool little shapes.
Yeah. A crystal is just that repeating pattern is a crystal
That's
pattern.
right. That's what the actual definition is. It's and I was like describing it more, but yeah. Okay.
Yeah. Got it. Yeah, you got it. You got it. What sorts of time frames do geologists study?
The past and the future.
Tell me a little bit more about both of those.
Like millions of years ago, and then also looking ahead to like predicting what's going to be happening with the Earth based on what's currently happening and my guesses and like patterns of like this is what typically happens right before an earthquake or things like that.
Yeah.
To predict things.
I'm sure you've learned about plate tectonics before.
Yeah.
And Pangea.
Yeah.
And we can predict based on the motion of the plates right now, how long it will take before we have another supercontinent, before all the continents come back together and they will eventually form another supercontinent. Not anytime soon. But eventually that will happen. Oh, I don't know. I'd have to look it up. When's the next supercontinent? Let's see what Google says.
Is it going to be called Pangea 2?
No, because Pangea is not the only supercontinent that we've had either. We've also had Rodinia and Laurentia and others that I don't remember off the top of my head. Well, let's see. According to Scientific American, the last supercontinent, Pangea, broke apart about 200 million years ago. The next, dubbed Pangea Ultima, so kind of like Pangea 2.
I don't know if that's much better than Pangea 2, Ryan. So
no, it's really not. Is expected to form at the equator in about 250 million years.
Wow, at the equator.
Yeah.
So everything's going to kind of come. It's going to be like a ring in the middle.
Could be. I'm not sure.
Or just like a blob.
On here. Here. It
this
looks
is so
like
interesting.
This.
Oh, so a blob. The equator is in the center of it. Oh yeah, there's Alaska.
Yeah, you can sort of see sort of South America and
Australia,
right? Yeah.
Yeah.
There you go. Yeah.
That's so interesting. Wow, that's really cool. Pangea
that's geology.
2.
Pangea Ultima.
Okay. Isn't that also like the name of a car or something like that? Ultima. Goodness gracious.
I don't think it's the Pangea Ultima.
Or is it an energy drink? I mean, that could be a number of things.
It could be lots of things. Yeah.
I mean, it doesn't have to be their final choice because there's like 250 million years to like decide on a name. So
that's true.
They won't be speaking English by that point, so that's fine.
No, I don't think so. Last question. Give 2 examples of things that geologists do.
They study a lot. Do you want specific, like a specific task or a job?
Yes.
A task? Okay. I can give you a task.
Or a job.
They drill a big old hole super far down, and then they like put a stopper on the end of it somehow, and then they like pull it back up, and then they look at like everything, like all the layers of everything. You look so confused.
Put a stopper on it somehow. What are they pulling up layers of?
Like soil samples or like the ice with the bubbles in it.
Okay, the ice.
Things like
there
that.
we go.
Yeah.
Okay.
To see like that layer from 65 million years ago with the special layer of dust. Like they probably had to do like a big old, just like shove a really big straw in the ground and then like stick their thumb on the end of it and then pull it back up and then release it on some sort of surface without jumbling them all up. Something like that. This is why I'm not the one in charge of these projects.
I can tell I might as well just do this now just because we already are. Here, I'll show you some pictures. This is just a Google image search, but here's that iridium layer.
Oh,
that's cool. The dark one, right? Or the light one in this case. Like you can see the, right?
Wow.
The iridium layer just right there. So like you can see it all over the place.
That's so neat.
So here's, and it's even like nice and impact layer, right? Iridium concentration right in there. See, you can see it all over.
Wow.
Cool, huh?
That's really cool. Yeah. Nice.
Okay, so
the
that's
other
one.
thing they do is they monitor volcanoes and what they're like, what's happening on the inside of the volcano to find out. I'm assuming they're trying to find out more than just when it might erupt, but one of the highlights is probably try to find out when it's going to erupt.
Yes.
Yeah.
Yes. Definitely true. Definitely true. Great. Look at that. You know about geology now, Cheryl.
Yay.
How much more would you say you know geology now than when we started?
Oh, like a lot. I just like I hear facts about individual rocks sometimes, but I think like I feel like this gives me such a better understanding of like a good overview and bigger picture of all the cool things they're up to besides just research, which is really neat.
That is great.
Yeah.
That's all the time we have for this week, though. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.